Today we're going to learn about domain and range for continuous graphs. So let me remind you that a continuous graph means that on the actual graph, the points are connected. Whether those points are going to be going on forever, like in number 1, this example, we can see that there's arrows going this way, and then it goes around and up, and then the arrow goes this way. This one's continuous. It does go on forever because of these arrows, but it's continuous because the points are connected. This one in number 2, I can see that this is a circle. So this is considered continuous because the points that make the circle are all connected. A continuous graph is a graph that doesn't necessarily have to go on forever, but it is a graph where the points are connected with a line or a curve of some sort. So all of these graphs we're going to see today are continuous. When we're trying to find the domain and range of continuous graphs, we cannot list them like we did previously. I repeat, we cannot list the domain numbers and the range numbers because it continues on. Like there's always going to be numbers in between because there's a line connecting them. So because of that, we're not going to be able to do it the same way we did previously. Now let me remind you that the domain are your X values, range are your Y values. So for domain, you scan your pencil left to right. And identify the X values in which you're touching the graph. So you look at it from an X perspective, left to right. You're looking at what X values, quote unquote, work for the graph. And then for range, you scan your pencil vertically. So you scan your pencil, I'm gonna say up and down. I don't know why these blanks don't make sense for that, but you scan your pencil, I guess we can say from the bottom, I'm going to cross this and, to top, and identify the Y values in which you are touching the graph. This is going to feel different than what we did previously. Previously, what we were doing with domain and range, if I said, what's the domain for this graph here? This graph previously, if I said, what's the domain for this graph? What I would do is list all of the X values that are on these ordered pairs. Like here's the smallest X value point. This is at negative 1, 2, 3, 4, 5. So the domain for this would start at negative 5. The next smallest X value point would be at this point here, which is at negative 2 on the X-axis. Then it would be this point, which is 0 on the X-axis. Then this point is at 2 on the X-axis, and then 1, 2, 3, 4. And this is at 4 on the X-axis. The domain would be those 5 numbers. The range, now we're looking at the Y values. So now we would go from the bottom to the top. The smallest Y value point would be this point here. This is at negative 1, 2, 3, 4, 5. So this is at negative 5. Next, the next smallest point on the Y-axis would be this point here at negative 4. Then next, we have this point here, which is at negative 3. Next, we have this point here, which is at 2. And then last, this point here, which is at 3. So notice, when we're finding the domain, we look at the X value only of the points. The smallest X value is to the left. The largest X value is to the right. For range, we look at the graph from a bottom to top perspective. The smallest Y values at the bottom, the tallest Y values at the top. Now, if I change the way that this graph looked, and instead of it being discrete the way that it is, if I were to connect these points, so let's say I connected the points and I have some sort of curve like this, I am unable to tell you that the domain are those same numbers that I already had erased. The domain is not going to be the negative 5, the negative 2, the 0, the 2, and the 4. It's not that way anymore because these points are now connected. When points are connected, you can't just say that the domain is only this number, this number, this number, this number, and this number, because that's not true. there's going to be points that are in the middle of those numbers, like here, 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 and everywhere. So you can't just list all of the points when a line connects them. So what we're going to do today is figure out, well, how do we list the points? How do we list the domain when the lines are there and the points are connected? And it's a completely different process. So if we go back to our notes, the first one that we have here is a graph where the lines clearly are continuous. The points are connected. The arrows actually show that it goes on forever. So if I was looking at this from an X perspective, I start on the left-hand side. So I'm going to start here. And when I start there, I realize that this smallest point is technically an arrow going on forever, which means the X values continue to get smaller and smaller and smaller. Now focus on this arrow's left and right position. I know this arrow is also pointing like up. It's pointing up and to the left, but we're only thinking about it from an X perspective. So only focus on the arrow pointing left, not up. So from a X perspective, this is going on forever, pointing towards the left. That means that it's pointing to negative infinity. So this arrow is pointing forever towards all the negative numbers, negative infinity. That symbol is an infinity symbol. With a minus sign in front of it, like a negative, it means negative infinity. And then to look at the largest X values, I just keep looking at the graph and I move all the way to the right. And on the right-hand side, I have another arrow. I know this arrow is pointing up, but we're not looking at it from a vertical perspective. We're looking at it from a horizontal, from X. And for X, this arrow is pointing to the right, and this arrow is pointing to positive infinity. So the domain for this one's interesting because, of course, we can't list it because that's impossible. How could we list every single point in between all of the integer points with the decimals and fractions for all the points that would make this line and then go on forever in that direction and that direction? That's impossible. So what we would do for this one and all of them is either use an inequality, or in this case, the inequality doesn't have to be used because the domain, the X values for this graph, are actually all real numbers. And what we use for this is a symbol that looks like an R with like an extra line through it. And the reason why the domain is all real numbers is because the X values continue pointing towards negative infinity and positive infinity. That's not going to be the case for all of these graphs. Like if I do want to focus on number 2. Number 2's domain, the X values, do not go on forever in both directions, and they are not going to be all real numbers. If I was looking at this graph from an X perspective, the smallest X value on this graph occurs right here when X equals -3. I know this graph is a circle, so the points that go around the circle, right? And then the line is connecting it around, and the largest X value that we would see occurs over here when X is +3. This one is not going to be all real numbers for the domain. The domain for this one is going to be anything from -3 to +3 for X. We already learned an entire unit about when we have situations where things are between two numbers, and it's called an inequality, a compound inequality. What we would do is put the X in the middle, and then we would use these symbols here, less than or equal to, less than or equal to. That's because -3 and +3 are both included in the actual endpoints. So that would be the domain for number 2. I'm not going to do just domain for each one and then come back. I just did want to show you the difference right away. The range. So for the range for number 1, back to number 1, now we're looking at this graph not from an X perspective. So I'm going to actually erase this. Now we're going to look at this from a Y perspective. So I'm going to change the color here, and we're going to look at this from a vertical standpoint. We go from the bottom to the top. So the smallest number on X, or sorry, not on X, the smallest number on Y occurs right here when Y equals -2. There's no point below that on this graph. That is definitely the smallest number, -2 for sure. The largest number for y, I look at the graph and I look for the highest point on this graph, and technically this is the higher of the two different points because the way this is slanted. And this point technically is not just a random point, like it's an actual arrow. So this is telling us that the highest point never ends. It just continues on forever. Because of that, that means that it's pointing to positive infinity, and the numbers continue to get larger and larger and larger for y. Well, the y values then are anything from -2 and up. So how we write that is an inequality. We don't have to make it a compound inequality like we did over here. We would just say y is greater than or equal to -2. And that's it. Number 2, the range there. I'm going to erase what I have here, and then I'm going to focus on what this looks like from a vertical perspective. So now I'm focusing on the y values. The smallest y value occurs down here when y equals -3, and the largest y value occurs up here when y equals +3. That means that my range goes from -3 to +3. There's no numbers that are bigger than 3 on this graph or smaller than -3. So the range is going to coincidentally look just like the domain because it's also going to be a compound inequality with -3 being the smallest number and +3 being the largest. I'm going to switch out x for y because range, remember, are your y values. And then I use these symbols to say that the range is in between -3 and +3. Moving right along, number 3, let's do domain first. So domain, x values. I look at this line, I can see that the points are connected, and I see arrows going in both directions. When you see arrows going in both directions, that's probably going to mean something is going to happen with domain and or range being all real numbers. For domain, if I was looking at the x perspective from left to right, the smallest number here on x is an arrow pointing on forever, meaning that the x values continue to get smaller. The largest the largest x value occurs over here, which is another arrow, which then continues on this direction, and the x values continue to get larger. The domain is going to be all real numbers for this line. The range, now we're looking at it from a different perspective, from the bottom to the top. The smallest point on this graph occurs like right here, but again, it's an arrow. This arrow is pointing down according to y. So this is meaning that the points are going to continue to get smaller and smaller and smaller. The highest point occurs like right here, but again, it's another arrow, which means that the y values are going to continue to get larger. The range is also all real numbers. This does not happen all the time. Number 4, domain. Looking at this from an x perspective, the smallest x value would occur right here, which is an arrow. I know this arrow is very clearly pointing down, but it's pointing to the left as well. Looking at the largest x value, remember, x is smallest to largest. We're only looking at x. We actually have nothing to do with the y values. Like this point up here has nothing to do with domain. The largest x value is going to be all the way over here. And this is another arrow, and it's pointing down and to the right. So because it's pointing to the right, that's what we're focusing on. I'm saying down because it is pointing down, but it's pointing down to the right. This one's pointing down to the left. So because this is pointing to the left and this one's pointing to the right, this one's going to continue to get smaller and smaller and smaller. This one's going to continue to get larger and larger and larger because they're pointing in opposite directions. The domain for this is all real numbers. But then the range is different. Now we look at this from the smallest point to the largest point. The smallest point would be a tie between here and here. Both of these are arrows, meaning that the points continue to get smaller and smaller and smaller. These arrows are pointing down. The largest point occurs all the way up here at this top point here, which is at +1, 2, 3, 4, 5. This is where y equals 5. There's no number that's bigger than 5 on the y-axis for this graph. So the numbers are 5 and below. We write that using an inequality. Y is less than or equal to 5. Now, I know that this is pretty difficult and it's actually very abstract. If you're like into art, I know that there's a difference when you start doing abstract art. It feels weird, and this is why, this does get a little bit more challenging when we look at continuous graphs. But this is how the domain and range for these type work. What I would like you to do is try numbers 5, 6, 7, 8, 9, and 10. So try these first. The answer key is going to be posted on the sideboard, where it usually is by my desk. And after you check your answers, stop and then work on the IXL. We'll come back to this tomorrow when I'm in class, but I did want to start it in case anyone's IXL had questions about this. So do this first, these 6 questions, check your answers, and then IXL.